Surface area is the hardest stuff in this. There's no question it's the hardest stuff in this section. Let's look at, now there's two kinds of surface area problems and really two kinds of volume problems that you see on the homeworks. There are the kinds where you're just given some dimensions and asked to calculate a surface area. Those can be hard, but they're pretty straightforward. You just have to find the formula and then plug stuff in. The other kind are the ones where you're given the surface area and some of the dimensions, but there's an unknown dimension that you got to find. To me, those are a little bit harder. We'll look at an example, at least one example of each. Now let's start off with maybe this one. So if we're trying to find the surface area, first of all we got to know what kind of thing is this. In order to find the formula, I got to know what is it. What is it?
It's like a right triangular prism.
It's a right triangular prism. That's exactly what it is. I do not care if you have all of the formulas memorized. You're going to forget them if you do anyway. Some of them you might remember. You need to know probably the circle ones, but the other stuff, I mean, it's when you need it, you can find it. You may use the formula sheet on the test. That's fine with me, but you need to know how to use it. So what is the formula for the surface area of a prism, any prism? Okay, so that's going to be for the base area. You're right. What about for the whole prism? The surface area of a prism is always what? 2b. Good. I've got two bases.
Plus pH.
Plus I've got the lateral area, which is pH. And we want to remember what those things mean. When you look at these formulas, it's easy just to write them down without ever thinking about what they mean. But it's important to kind of keep track of what those terms mean. Okay, so the 2b part, this is the two bases. And then this pH part, that's what we call the lateral area, right? The lateral area is, this distance around, it's all this stuff in here. It goes around that way, and then it goes that bottom side, and then it goes up that side. Those are the sides we're talking about, those areas, right? Okay, so let's calculate the base area first. And I'm going to pull up a calculator. We'll just do this stuff. We've got access to those graphing calculators. Don't you agree those things make it a lot easier? If you didn't have one to begin with to work with, using one of those I think is very helpful. So you already told me that to find the base area, we're just going to multiply 1/2 the base of the triangle times its height. Right, so we end up getting something like this. Base equals 1/2 times x, which is 8.5 times y, which is 2.3, and we can put that in our calculator or just go grab that number anytime we want to. So 0.5, 1/2 times 8.5 times 2.3 is that. There it is. Now we got it. Okay, what about, it looks like we need perimeter. Okay, well, perimeter is just going to be the distance all the way around this thing, right? So for perimeter, we're going to have, there's that side, which is x, so that's 8.5 plus that side, y, which is 2.3. But what about that side? What's the length of that one? It's not given to us directly. Okay, we know by the Pythagorean theorem, we know that's the hypotenuse of a right triangle, right? So it's always going to be equal to the length of that side squared equals x squared plus y squared, right? So then this side must be the square root of x squared plus y squared. So plus the square root of 8.5 squared plus 2.3 squared. And I feel like people are getting really good at using the Pythagorean formula now. You use it a lot. That's one of those things that comes up again and again. In fact, that to me, that's the kind of stuff, if I think about the things that I ever do in real life other than teaching math or doing computer programming or things like that, just kind of everyday stuff, this is it. I'm just, like this summer, for example, I just built a bunch of, I had to build a shed and build some things like that. And when you do that kind of thing, you actually use some simple geometry. Like for example, when you want to build a structure and you want to make it square, well, the way you make it square is if you know how long the sides are, say of the shed, then you can just quickly calculate what the hypotenuse would be, and you can run a measuring tape from there up to there, and just flex the sides until they're the right length, until they're the length predicted by the Pythagorean theorem, and then you know you've got a perfectly square structure, which you have to have, or things don't work out very well. So, so this kind of stuff, you'll come back to again and again. This really is very useful. All right, so the perimeter then. Let's do that calculation. So 8.5 plus 2.3 plus the square root of 8.5 squared plus 2.3 squared. Everybody agree that's it? There it is. Evidently it's 19.6 blah, blah, blah. It's in our calculator now, though. So when we want to do the entire calculation, we've already got the stuff in there, right? If we want to calculate surface area, it's just 2 times base. So there's 2 times, that number right there is my base, so I'll just go up and grab it. So 2 times that, 2 times the base, plus the perimeter, which is that number, times the height. Now, the height of the prism, which of those dimensions is the height of the prism? Z, okay, and Z is 1.3, right? Right there. So we'll multiply the perimeter times 1.3, and we got it. Okay, there's our surface area. Make sense? Okay, no big deal. No big deal. Now, we could do other examples of surface areas if we wanted to, but they're all pretty much the same. If we looked at this one, for example, it's the same idea. What's the only difference about this one? It's a prism, but what's different about it?
It's a trapezoid.
It's a trapezoid, yeah. So the only difference is now when we calculate the base area, when we calculate the base area B, it's just going to be the area of a trapezoid, right? And P is going to be the perimeter of the trapezoid. And we have those on the formula sheet. Does that make sense? Okay, so maybe I won't go through that complete example because we just did one like it. Okay, what about one like this? Now here's one of the other kind. This is one where we're given a surface area and we're asked to find a dimension A. All right, so how would we maybe go about this one? What do you think? And we have use of the graphing calculator. That's helpful. Suggestions where we might start with this. What do you think?
Write the equation.
Good. Always start with the formula. Perfect. So once again, we got a surface area of a prism, so it's 2b plus ph, right? And which one of those dimensions up there, where does a fit into this?
H.
A is the height of the prism, isn't it? Okay, so we could put the a right there. And that's what we're trying to isolate. So let's do the same stuff as before. Let's calculate what b is on the calculator. Let's calculate what p is. And then we can use those calculations in our solving for a, right? Okay, so if we want to find b, b is just this time it's an isosceles triangle, right? But still just a right triangle. So it's 1/2 the base of the triangle times the height. So then don't you agree that the base of the area of that triangle is just 0.5 times 17 times 17? 1/2 the base of the triangle times the height. So there it is. Okay, 144.5. Now what about the perimeter? Okay, if we want to add up the perimeter, that's going to be this side plus that side. Well, those are both 17. So 34. That part of the path around the triangle accounts for 34. Plus, what about this one? What's that going to be? It's a hypotenuse, right? So we know it's the square root of what? 17 squared plus 17 squared. Okay, so we'll add that to the 34, and then we've got the whole perimeter. Plus the square root of 17 squared plus 17 squared. And there it is. That's our perimeter. So we got them both. Well, now let's just go back and see what it takes to get that A by itself. Okay. What are the steps we would go through? And we know what the surface area is too, don't we? That's given to us as being 791, right? So we know this is 791. Okay, what are the steps we would go through here to get the A by itself? What do we do first? And how do we know? We reverse order of operations. Right, PEMDAS backwards. So that's the order in which we go through the steps. So the first option is adding and subtracting. Anything we need to add or subtract from the right side to get the A by itself? Yeah, we got to subtract that term, don't we? Because it's being added. It's being added to the A term, right? So subtract 2B from 791. So we'll start with 791 on the left side, and that's where our answer is going to end up, right? We know A is going to be by itself on the right, and whatever number is on the left then must be equal to A. So 791 minus 2 times the base area, which was, I got to go up and grab it, right there, right? 144.5. Okay? And that gives us that. Okay? And this term is now gone. Now what do we have to do? What's the next step to get the A by itself?
Divide by the perimeter.
Divide by the perimeter. The perimeter is being multiplied by A, so to undo that, we divide by P, right? So take that answer divided by the perimeter, which is right there. So I'll go up and grab that number. And there it is. We got it. Okay. Now we've got the A by itself, and that's the number, 8.65, rounded to 2 places, that's on the other side. Okay, questions on that? That make sense? Okay, you will have the calculators available. I don't have them today, but I'll have them, I think, pretty much every other day. Okay, what's next? Let's see, we can skip that. That's another one, just like the one we did. What kind of a creature is that? Not a cube. It's a rectangular prism, isn't it? Now, if we wanted to solve for A, it looks like A is this dimension right here. Any advice about how we might want to orient this rectangular prism? Which would we choose to be the base faces? What do you think?
Y and W would make the sides.
Okay, good. We'd want to choose the front and the back, wouldn't we? We don't have to. It would work the other way, but it makes the algebra a lot easier if the quantity that we're solving for is not included in the base. Not essential, but helpful. All right, moving on. Okay, it's more of the same. What about this? Let's look at a cylinder. Personally, I think cylinders and cones are easier than prisms and pyramids. Do you agree? Seems like the pyramids and having all those straight edges on there makes things difficult. When we're dealing with prisms and cylinders, we know that the bases are always circles, and they're always predictable, they're always the same. So if we want to solve for A, what is the formula for the surface area of a cylinder?
2 pi squared plus 2 pi.
Okay, good. We get 2 times pi r squared plus 2 pi rh. Now, what does the 2 pi r squared really represent? If you remember, we're adding up all the surfaces of this can, this cylinder. What does the 2 pi r squared mean then about the bases? I've got pi r squared is just the area of a circle, so these are the two circular caps of that can, right? And then the 2 pi rh, well, that's just the barrel part, right? That's the lateral area, okay? So we know surface area is 571. And we know that the radius is given to us as being 9, right? So the only thing we don't know is the height, and that's A. Oops. And that's what we're solving for. So how do we get that A by itself then? We know that the surface area is 571, so that's the what's already on the other side. What do I have to do to get the A by itself?
Subtract the 2 pi r squared.
Good, I'm going to subtract the 2 pi r squared. And we could calculate the 2 pi r squared separately if we want to, or we can just subtract the whole thing. So 571 minus 2 times pi times 9 squared gives us that. Okay, and we've gotten rid of that stuff. Now what? Divide by, what do I have to divide by to get the A by itself?
2 pi.
Yeah, I got to divide by all of this stuff, don't I? I got to divide by 2 pi r. Okay? So if I do that, divided by, now if I want to divide by three things being multiplied together, what do I have to be very careful about? There's a really common mistake. A lot of times people want to do this. They want to say answer divided by 2 pi times 9. What's wrong with that? Yeah, I have to put parentheses, or the calculator, which is smart enough to know order of operations, will do what I told it, which is my answer divided by 2, that result times pi times 9. That's not what I wanted. I wanted to divide by all that stuff. So I got to go back. And I've got to put parentheses around the whole denominator, right? Now if I hit enter, I got it. I got rid of that stuff, and A is 1.097, so the two places, 1.1, 1.10. Okay. All right. Okay, this guy. This is the hardest problem on any of it is got to be this one. This is a truly tough problem because, and we went through this in class once. I don't know if we'll spend. It's on. There's a video of this already. I don't know if we'll go through the whole thing again. On the test, I gave you, I think, one of these hard ones to do, but it's only worth 3 points on the whole test. So it's not, even if you didn't get it, you could still get an A on the test. This is really sort of the icing on the cake if you want to get an A+. What I'll say about this one is, so you can just kind of remind you how this goes. How am I going to find the surface area of a compound shape like this? What do you think? Here.
Get the surface area for the shapes by themselves.
Okay, I got to get the surface areas of the shapes by themselves, but I have to be careful with that because when I put shapes together, sometimes parts of their surfaces go away and they're no longer on the outside. Now, this is a combination of a prism and a pyramid, right? So if I look at the formulas for the surface areas, we already know that the surface area of a prism, we've dealt with that today, is 2b plus pH, where b is the base area, right? And pH is the lateral area of the prism. For a pyramid, we get, it's only got one base, doesn't it? Just on the bottom. Plus 1/2 PL. So it's got its base plus its lateral area. Now, if I add up these shapes together, how many total bases are there on this weird combination that I've created? There's only one on the bottom, right? So if I wanted to come up with kind of a weird hybrid surface area, the surface area of that thing would just equal one base plus, I've got to do the lateral area of the prism, so that's going to be that guy, plus the lateral area of the pyramid, which is that term. So I've got to be kind of pick and choose, don't I? Now, calculating those areas is not easy. What kind of shape is the base?
Hexagon.
It's a hexagon. So we know that if the base is a hexagon, that's just equal to 6 equilateral triangles. That's how I remember it. There's actually a formula that I give you on the sheet that directly calculates the area of a hexagon. But I always just remember it's 6 times the area of an equilateral triangle with side length x. And that would be the square root of 3/4x squared, right? So I could plug in x, and that's how I could calculate the base area. That's not that big a deal. The perimeter is pretty easy. What's the perimeter going to be? Yeah, if I know this has got 6 sides, and one of the sides of the base I'm talking about, and one of the sides of the base is length x, then it's just 6x, isn't it? So that's pretty easy, too. The part that's hard, honestly, the part that's the hardest is finding L, slant height. That's a little tricky. If you want to find slant height, the best recommendation I give you is you got to make a right triangle that looks like this. We've got C, which is given to us. Z is, in this case, is 17. So that's given to us. But then we've got to calculate this distance right here. Can you see that, what I'm doing there? It's going to go from the center of that hexagonal base of the pyramid out to the halfway point of one of the edges, right? And so that's not a quantity that's given to us. We could call that A. It's actually called the apothem. And if we were to there's an equilateral triangle. Can you see that? Kind of on its laid down on its side. You gotta stare at this stuff a little bit. Does that make sense, what I've done there? Okay, if I pull that triangle out, here it is. And there's A. Right? So we could calculate A because we know that if I take one of these right triangles here, I know that it's got a side that's 17, that's half of 17, so that's 8.5. So I could calculate A, couldn't I? Right? From the Pythagorean theorem. And then if I knew what A was, now here's the part that's really tricky, then the slant height is right there. You see that? So I've got a new right triangle now. This one comes out like that, and that's L. L goes up the middle of that face. Yes, sir?
If you're talking about the flat one, it's not going to have a side that's 17 because Z is 17 and not the.
Oh, hold it. Sorry, what's X? 9. I meant 9. Yeah, you're right. X is 9. Whoops. I better fix that. Yeah, I put the wrong number in. Everybody see that? This one should be, that should be 9 because that's what X is. And then this should be 4.5. Good eye. Okay? And then this triangle up here, if I pull this one out, and that's a little bit strange. If I pull that one out, I've got, that's the height, which was 17, the height of the pyramid. Here's that A that we would have calculated. And then there's slant height. So whatever A I get, I could use that number to find L. It's a lot of stuff. What? Yeah, go ahead. Now that's a tough one. I'll grant you that's a tough one. And I mean, if you could get everything in the chapter and not be able to do that one, you've still done pretty darn well. That's kind of that's a really challenging problem. But if you put your mind to it, I think you can. All right. So I think that does it for what we need to talk about. Yeah, I think so. I think we're okay. Why don't we head on down?